Okay, welcome back, guys. Today we're going to learn about how to use the Pythagorean theorem and its converse to solve problems. But before we delve into that, I want to review the problem of the day from the previous lesson, lesson 4-4, which is when we were using geometric means to find the length of segments and similarity relationships in right triangles. So the first question, it says, using the information given below, which set of triangles cannot be proven similar? So our job is to figure out what set of triangles cannot be proven similar. So let's look at the first one. So this looks like it's going to be side, angle, side, but we need to confirm that the sides are actually proportional. So we know that this side, AB, corresponds with RS. So it'll be 12 over 4 is equal to 9 over 3. Now, if we cross multiply, if we get the same number, that means it's proportional. So 4 times 9 gives us 36. 3 times 12 gives us 36. So we know that they are proportional. So we can use side, angle, side similarity here. So we can eliminate that answer choice. The second answer choice gives us 2 corresponding and congruent angles. And we know by angle-angle similarity that these two triangles will be similar. The third one, they gave us 2 sides and a corresponding angles. It's actually 2 consecutive sides and a corresponding angle. Well, that doesn't satisfy any of the postulates or theorems that we learned. It also doesn't give us enough information to show that all of the sides are proportional and all of the angles are congruent and corresponding. So right now it's looking like it's going to be 3, but let's check answer choice number 4. So we have a side that is corresponding to this side, an angle that is corresponding and congruent to this one, and a side. So this looks like side, angle, side similarity will work. So our answer choice here is going to be 3, okay? Now moving on to the next question. It says, in the diagram below, triangle ABC is similar to triangle DEF. It says that AB is 6, AC is 8. Which statement will justify similarity by side, angle, side? I circled here answer choice number 1, but let's look at the other choices. So if DE is 8, so let's look for DE, 8, and DF is 10, right? If we cross multiply, 6 over 8 is equal to 8 over 10. We're not going to get the same number. So this is going to give us 60, and this is going to give us 64. So that's not proportional. So we can eliminate that. Same thing here. Let me just erase this. If DE is 36 and DF is 64, let's see, 6 over 36 is equal to 8 over 64. Now, 6 times 64 gives us 384. So that's 384 when we cross multiply. And 8 times 36 times 36, that gives us 288. So it's not proportional, as you can see. So we can eliminate that one, right? Now let's look at the last one, answer choice. If DE is 15 and DF is 20, so let's see. So it'll be 6 over 15 is equal to 8 over 20. When we cross multiply, well, 6 times 20 is going to give us 120. And 8 times 15, it also gives us 120, right? So far the sides are proportional here. Let's look at the angles. Angle C and angle F seems to be corresponding, right? So this also looks like this could potentially be the answer. So let's go back up to question number 1. All right. Let's look at it. Let's look at it again. So if DE is 9 and DF is 12, right? So DE is 9, DF is 12, so 6 over 9 is equal to 8 over 12, right? Well, 6 times 12 gives us 72, right? And 8 times 9 is 72 as well. So notice that both of these sides are proportional. And the angles, so angle A corresponds with angle D, right? And so does angle C correspond with angle F. So both of these look like they can be the answer choice. However, let's go back to the question. It says, which statement will justify similarity by side, angle, side? Well, if we were doing this one, right? Given the information, it would not be side, angle, side, right? But for this one, for the first one, that's the only one that gives a side, angle, side similarity. So the answer choice here is 1. Even though answer choice 4 checked out to be proportional and the sides are corresponding and congruent, we have to look at which one gives a side, angle, side similarity. And based on the given information that was given, answer choice number 1 is the only one that gives a side, angle, side. All right, similarity. If you have any questions, just feel free to send me a comment on Google Classroom. Now for the last question, it says, in triangle SCU shown below, points T and O are on segment SU and segment CU respectively. Segment OT is drawn so that angle C is congruent to angle OTU. So angle C is congruent to angle OTU. So now, in seeing this triangle, right, I'm noticing that even though it looks like a smaller triangle is within a bigger triangle, I can tell that this angle and this angle are in 2 separate places. So you will have to rearrange it so that these 2 angles correspond. That's just a heads up. So now let me write in all of the other information. So TU is 4, OU is 5, OC is 7, and they want us to find ST. Now, what I taught you guys before is if we see overlapping triangles or a triangle within another triangle, separate those triangles. And that's the easiest way to see the proportional relationship, okay? So I'm gonna do that right here. So let me redraw my bigger triangle, and this is my smaller triangle, all right? So the bigger triangle is USC. So the sum of 7 and 5 gives us 12, right? Yep. And this side, X plus 4. And this side with T, well, actually, because we want the 2 angles to correspond, we're gonna put T right here, right? And then O here, right? And then U. So UT is 4 and OU is 5. So now we can clearly see the proportional relationship and we can set up our proportion. So we want to do 5 over x plus 4 is equal to 4 over 12. And we will cross multiply. So we get 4. Let me do the work over here. So I'm running out of space. So we will get 4 parentheses x plus 4 is equal to 5 times 12, which is 60. So we get 4x plus 16 is equal to 60. Additive inverse of 16 on both sides. So we get 4x is equal to 44, and therefore x is equal to 11. So the length of T will be 11, and that's answer choice 3, okay? Please take a minute to copy it down. and then we'll move on. Okay, so now I just wanted to go over this opening exercise really briefly. So your job was to draw a diagonal of a rectangular piece of paper to form two right triangles. In one triangle, draw the altitude from the right angle to the hypotenuse. Number the angles as shown. Cut out 3 triangles. How can you match the angles of the triangles to show that all 3 triangles are similar? Explain how you know the matching angles are congruent. So, with this is basically what the previous lesson was about. So if we look at just this triangle here, right? As you can see, the altitude is drawn in the much bigger triangle, right? And let's refresh our memory. An altitude is a segment which is drawn from the vertex of the triangle to the opposite side, which is the hypotenuse, and it's going to be perpendicular, all right, to that hypotenuse. Now, when you separate the triangles, the 2 smaller triangles will be similar to the bigger triangle by angle similarity, okay? So after you have separated them and redrawn it, you will get something like this. So this is my much bigger triangle here, right? That's my much bigger. This is the medium sized triangle. And this is going to be the smaller triangle. Okay. So all 3 of them have the right angle in common, right? So that makes one angle. And then all 3 of them must have another angle in common, right? So by angle similarity, let's write it in the space here. All 3 right triangles must be similar because of angle similarity. All right, they all have 2 angles that are corresponding and congruent, okay? And that's what you should have. And that's what we were looking to, that's the answer that we were looking to arrive at once we have rearranged all of the pieces of the rectangular sheet of paper that we cut into 2 right triangles, okay? Great.